Welcome to section 5.4, day 2, sum and difference identities. Today we're going to use sum and difference identities to write trigonometric expressions as algebraic expressions, and we are going to verify identities. First thing we're going to do is verify different identities. This first one here, we're going to verify odd and even identities using our sum and difference identities. If we have cosine of negative theta and we want to show that it equals cosine of theta, we can rewrite the left side into a difference. This is the same as cosine of 0 minus theta. So that's what we're doing. We're taking this piece. Cosine of negative theta is equal to cosine of 0 minus theta. And we just rewrote it as a difference. We are doing a verify, so we do need to explain what we're doing every time. We now have a difference, so we can use our cosine difference identity. When we do this, we have the cosine of the first, which is cosine 0, times the cosine of theta. And we have a difference, so we're going to do plus the sine, this is right off of our identity sheet, of 0 sine of theta. And we just use a difference identity. And we just put diff identity. Then we can evaluate what we can, and the cosine of 0 is 1, leaving in 1 cosine theta. The sine of 0 is 0, and we get 0 sine theta, and we evaluated. And then from here, we just simplify it out. We have 1 cosine theta, which is just cosine theta. We have 0 sine theta, which is just 0, and we simplified. And then we have shown that cosine of negative theta is indeed cosine theta. So we put in our little statement, therefore cosine negative theta equals cosine of theta. And we put a little box at the end. Here it says to verify that cosine of theta minus pi halves equals sine of theta. Again, we have a difference. This one's already written as a difference, so we can go right to our difference identity. To start off, I should do this. Cosine theta minus pi halves is equal to, and we're going to use our difference identity. So cosine theta cosine pi halves plus sine of theta sine pi halves, and we just used our difference identity. We are then going to evaluate. The cosine of pi halves is 0, so we have cosine theta times 0 plus sine of theta times 1, and we just evaluated. From here we simplify. Cosine of theta times 0 is 0, sine of theta times 1 is the sine of theta, and we simplified. And now all we have to do is make our statement, because we've shown what we wanted to. So cosine theta minus a half does indeed equal sine of theta. Almost forgot my little therefore and my box. We've just shown that cosine of theta minus pi halves is indeed sine of theta. Here it says to verify tangent of pi halves minus x equals cotangent x. For this one, we need to use our tangent identity, and it's our difference. We take tangent of pi halves minus x. We want to show it equals cotangent, so we're going to change the tangent of pi halves minus x and use our difference identity. We have tangent of pi halves minus tangent of x all over 1 plus the tangent of pi halves tangent x. And we did use a difference identity. Okay, from here we're going to evaluate it, and hopefully you'll notice when you try to evaluate this, the tangent of pi halves would be sine over cosine, which is 1 over 0, and tangent of pi halves is undefined. It's where our asymptotes are. So what we have here is an identity that's not possible. This is not possible. We can't go any further. We got to a place where this is not possible. And sometimes when we do want to try to verify an identity, we find out it does not work. This one does not work. Here we go. We're going to verify that tangent of x minus 360 degrees equals tangent of x. Again, we're going to go through our process. We have a difference. So we're going to change this into tangent. We're going to use our difference identity. So we have tangent of x minus tangent of 360 over 1 plus tangent x times the tangent of 360. And we just use a difference identity here. That's what a lot of these are, just using identities as we go through. We then evaluate. We can't do anything with tangent x. We have no idea what x is. The tangent of 360, the sine there is 0. The cosine is 1. So we have minus 0. To the bottom, we have 1 plus the tangent of x times that tangent of 360, which we found out was 0. We evaluated here. So make sure you're saying what you did. Finally, we take the tangent of x, we simplify what we have. And 1 plus tangent x times 0 on the bottom just is 1. So we simplify this, all we get back is tangent x. Because the denominator goes just to 1. So then, therefore, the tangent of x minus 360 equals the tangent of x. And we have just shown that this is true. All right, that's verifying identities. Make sure whenever it says to verify, you write down every step you do, one step at a time, and what justification you have to do that step. Last slide for the day, solve a trigonometric equation. We want to find the solutions of sine of x plus pi fourths minus sine of x minus pi fourths equals 0 on the interval from 0 to 2 pi. Here we have a sum and a difference for sine. So we're going to use our sum and difference identities to solve this. So if you use your sine identity for a sum, you take the sine of the first times the cosine of the second plus the cosine of the first and sine of the second, and then we do minus, and make sure you put this in brackets or big parentheses. We're going to do a difference identity for the sine of x minus pi fourths. We get sine of x, cosine of pi fourths, minus cosine x, sine of pi fourths, equal to 0. And we just use the sum and difference identities. And then we have two options from here. We can evaluate what we have, or we can distribute the negative sign through. I will distribute the negative sign in. So we have sine x cosine pi fourths plus cosine x sine of pi fourths minus sine of x cosine pi fourths plus, and I'm going to go down here a little bit, cosine x sine of pi fourths, all equal to 0. Okay, when you look at this, hopefully you'll see that we have some like terms that we can combine. We have a sine x cosine pi fourths and a negative sine x cosine pi fourths. These are going to cancel out. Oh, and I forgot to put what I did. I did distribute. Okay, so then we have a cosine x sine pi fourths and a cosine x sine pi fourths. That means we have 2 cosine x sine pi fourths equal to 0. All right, so we have 2 cosine x sine pi fourths equal to 0. We evaluate our sine of pi fourths. So we have 2 cosine x. The sine of pi fourths is the square root of 2 over 2 equals 0. When we multiply these together, 2 and the square root of 2 over 2 becomes the square root of 2 cosine x's equals 0. We're just doing algebra now. We're going to divide by square root of 2. We get cosine of x equals 0. And so we want to find out when the cosine of x is 0 on our interval from 0 to 2 pi. And this happens when x is pi halves or 3 pi halves. This is my solution. You don't have to show, like I wrote on the side here, what I was doing, because we're doing an equation. I was writing it down so you could see what I was doing. For equations, you do not need to justify your steps. Just show me the work. For verifying, you do need to justify each step. That is all for 5.4 day 2. Today we're using sum and difference identities to verify identities and to solve equations. Thank you for watching and have a nice day.